Good afternoon, everyone. This is Team 7. We are going to present our project Swine Disease Classification using deep learning models. Next slide, please. So the agenda for today starts off with project presentation, project introduction, data engineering, and followed by we're going to explain our machine learning models that we employed for the project and the comparison of the results for these projects. It is followed by the design and development of web system and the implementation of the system design. In the next slide, we're gonna start off the project introduction with project introduction, background, technology survey, literature survey, and the roadmap. So starting off with the introduction in the next slide, in the field of agriculture, particularly in swine industry, respiratory diseases possess a significant challenges affecting both animal welfare and industry economics. So accurate and timely disease identification is very crucial for effective disease management. So leveraging the cutting edge technologies like deep learning applications shows a promising applications in veterinary sciences. So the ability of deep learning models to process complex data such as audio signals enables advanced analysis and classification of animal sounds. The primary objective of our project is to employ and develop a robust deep learning methodology to classify the swine diseases accurately. We also aim to develop a user interface for effective and easy classification of diseases. So, in classifying the swine disease, there are challenges in the diagnosis methods, where conventional diagnosis methods often need more speed, more accuracy, and scalability. So, we can the need for this innovative challenges can be solved revolutionizing disease monitoring, prevention, and treatment strategies. So, our initiative holds a tremendous potential for enhancing the livestock health and agricultural productivity. Moving on to the background, so the respiratory diseases in swine industry are a major impact which affects 35% of the pigs in swine herds and with an annual economic loss of over $600 million. As discussed in the earlier introduction, there are challenges while diagnosing the diseases. So these conventional diagnosis methods such as visual inspection, serological testing often limit their accuracy rates, which ranges about 60 to 80%. But whereas these conventional neural networks, which are in the deep learning models, have shown a significant improvement in the classification accuracy rates, which exceeds about 80%. So there is a survey conducted where most of 80% of the swine veterinarians expressed a critical need for more advancement in the effective diagnostic system to combat this respiratory diseases in the swine. So moving on to the technological survey, there are various projects conducted in swine disease diagnostics using audio and video data sets. So there is a project in China where fusion of acoustic and deep features for pick off sounds were conducted, where they use microphones and sound cards to record the audio data of the swine. And they have employed support vector mechanism, and it also shows that they need combining the acoustic and deep features give improves the accuracy to 97.35%. And there are a couple of other projects in China wherein investigation of acoustic and visual features for of pig cough classification are conducted using support vectors and KNN random forest, which found out that combining both visual and acoustic features also improved the accuracy rates. And there is this one more project in which is conducted in China where DenseNet models and are used to improve the pig sound recognition systems. They also said that DenseNet models improve the accuracy by 0.5 percentage, 0.9 percentage. Moving on to the background literature survey of this project, there are various papers on recognition system for pig cough based on probabilistic neural system, wherein they employed PNN model, where the probabilistic neural networks are utilized for novel neural network methodologies. And we have also MFCC and LSTM ResNet models where vocal recognition are used for animal disease classification. So this says that various MFCC parameters are extracted from the original frequency of the audio cuff sounds. So this also improves the accuracy of the systems. And there is this last method, efficient net and ResNet, wherein the deep learning models are employed for filtering the noise of the audio sounds. So this and so moving on to project life cycle, the project life cycle starts with the collection of audio and image data for our project. In the pre-processing stage, all the noise and clarity of the images are extracted, and the data preparation, MFCCs and pre-trained V3 are used for the preparation of data, and this prepared data is used to train the model development, and the evaluation methods are used to compare the model results of various models, followed by model deployment. Now, Kishore will continue for data engineering.
So continuing on data engineering, the separate different steps in the data engineering which can be seen as in the data flow diagram. So we want to explore the maximum disease ranges. So we went for two organs that mostly affected. One is respiratory diseases and skin diseases. So we are dealing with two kinds of data as we are dealing with different kinds of diseases or different kinds of targeted organs. So the first step is about data collection where we collect different kinds of audio samples as well as image samples. Then we do data pre-processing. As there are two different kinds of data types, we have to do different data pre-processing as well as the feature extraction. So in feature extraction, we extract the features from the audio data as well as image data. Then we prepare the data preparation where we crop or where we split the data into 60, 20, 20%. And finally, the data will be prepared or we can say as made for the modeling purpose. So coming to the data requirements, so we have different tasks and data characteristics we are looking for. So when we selecting data, the main target we have in our hand is like we need to do cup sound analysis. So we have to find a data of audio recordings of swine curves. Then we have to do detection of swine behavior anomalies. So to detect the anomalies, we need to know the normal behavior. So we need to get the normal cuff sounds. Classification of swine cuffs, labeled data set of cuff audio recordings, skin disease classification. So for this one, we need high resolution skin images. Identification of common symptoms through image analysis. So for this task, we need data or the data which we are collecting, we need a diverse data set of skin lesions associated with swine diseases. So coming to data collection for image. So first we have to understand what are the diseases we're dealing with. So we learned about different common skin diseases in the swine. So then we downloaded skin images from different data sources, starting from Iowa State University Center for Food Security and Public Health, Cornell Veterinary Medicine, and Google Search. So we topped up the whatever results we got from this thing with our Google search to add some more diversity in our data sets. So totally we have 13 different skin diseases ranging from African swine fever to swine disease or swine vascular diseases. So coming to data collection for audio, we got our hands on a set of audio clips, so which has a cuff sounds, normal cuff sounds, as well as affected cuff sounds. So the cuff sounds are of three categories: pneumonia, porcupine reproductive and respiratory syndrome, and African swine fever in swine. So data preprocessing for audio. So for audio, we extracted MFCCs from the audio. So before that, to enhance the model performance, we did augmentation. So we applied augmentations like random flip, adding the noise and removing the noise, stretching the audio, this kind of things for the augmentation. Then before selecting all the augmented files, we did an objective evaluation method called signal to noise ratio. So whenever the signal to noise ratio is above greater than 10 decibels, it's a good audio. So we collected those samples, like what are the augmented samples or gone through this objective evaluation as well as subjective evaluation before selecting for the final as an input. So data augmentations in this also includes pitch shifting, stretching, accelerating, and adderness. As you can see in the sample, so length of clean audio, length of augmented audio. So then it's calculated the decibels signal to noise ratio for the different augmented files. So if it's If it's more than 0 decibel, more than 10 decibels, then it'll, augmented data will be saved. Otherwise, augmented data is not being saved here, as you can see in the below sample. So data pre-processing for image. So the first step is like read image from path label as for the folder name, resize the image to 224, 224. We did several trials and we decided for this number, and it's most commonly used, and decode the image from JPG format to tensor format to obtain the pixel values at color channels. So then we did image augmentation to add random flip, rotation, and contrast. Pre-processing of image specific to the mode, which typically involves normalization and transform to format expected by the model. As you can see in the picture, it's the code disputes the image reading and pre-processing. So this is a preparation, data preparation, data flow. So as you can see, there'll be users having access to the input data, so which will be stored in a database. So through database, from this database, we do data pre-processing, and again, the data will be saved in the same database. So from that, after data pre-processing, we'll be doing the data preparation step. So data preparation, then we do run the models on audio disease classification, then we do the image classification to detect the swine diseases. So coming to the feature extraction for audio data using MFCCs. Extracting MFCCs includes several steps like pre-emphasis, frame blocking, FFTT, M filtering, and log filter. The results coefficients represent the compact features capturing the essential audio characteristics, which serves as valuable features. Feature extraction for image data. So a pre-trained CNN, we here in this aspect of the project, we call it as Inception V3, is used to extract the features from the pre-processing images. So coming to the data preparation for the audio dataset, so we split the dataset into 60-20-20 ratio for the training, test, and validation. So as you can see in the screenshots, as well as snapshots and the diagram, the number of data points in train, test, and validation from the different three classes we have, which is like pneumonia for pneumonia, African swine fever, and PRRS. So coming to the data preparation image, so we have to maintain the consistency account throughout the project. So we divided the data set into again 16-20-20 ratio for the training, test, and validation. So here is a samples of, here is a visual representation of number of images from each class in the different kinds of data split. So here is a big data statistics for the data analytics results. So pre-processing, we have like two kinds of data set. One is like this is audio data set, and this is skin disease, which is like image data set. So for the data set, we have pneumonia, PRS, and African swine fever. For data set, we have only skin disease mentioned as like 215 samples. So end of pre-processing, we have like the whole samples will be combined into one. So data transformation. After data transformation in audio dataset, class level dataset is 974. After MFCC after feature extraction, we have 180 rows and 2 columns. So to have enhancement to work well for the model, we parrot the data. So after padding the data, the data transformation, the statistics is 1080 rows and 380 columns. Come to data preparation. So after splitting the data, this is how these many rows are there in training, test, and validation. Coming to image, see again in the like the normal data set or input data set is 215 samples. After processing, we have 215 samples, and after extracting the features, we have 215 rows and 2028 columns. Again, after splitting from 10 test and validation, 155 rows, 52 rows, and 50 rows, which is like 60-20-20. So here are the few visualizations of data analytic results. So here is after, as I told you, we did data pre-processing. So original data or original audio duration, and here is the augmented audio duration. So we have after augmentation, as you can see here, after African swine fever has 18 input files. After the augmentation, we have 126 output files. Similarly, pneumonia, we have 700, and PRS, we have 120 output files. So here is a few visualizations to show the distribution of the data we have. So coming to the data analysis for the results for the images. So as I told, as you've seen in the earlier, number of images in each category shows here, and mean values of the features. And here is a statistics of the image, label, mean, standard deviation, and count, and other kind of statistics for this one. So next part, machine learning models and comparison will be spoken by Rajiv.
Well,
Sorry, Hrithik.
hi, this is Ritik. Coming to machine learning models and comparisons, we dealt with three kinds of models for audio dataset and the two models for the image dataset. Coming to the audio dataset, we gone through DenseNet. Next slide, please. The DenseNet we dealt with for the audio files, in which DenseNet architecture comes to a dense convolutional network (DCN). And here these nodes are linked together in a specific order, where each layer connects to every other layer in a feed-forward fashion. To improve how futures propagate, leading to a better future learning, in which here you can see the audio files which are converted into the MFCC feature extractions, which are then fed into a series of dense layers with ReLU and dropout layers in the between. The final output layers and predicts the classes of audio, for example, pneumonia. And here comes the proposed model, in which, and you can see in the red box, where the ReLU activation function to introduce non-linearity, and also comes to the dropout. Here, what it does, it's preventing the overfitting, which is used to give the clear output. Next slide, please. As we discussed, here the activation function is used to for nonlinearity, and again dropout is for the preventing the overfitting. Yeah, at last, output shape is 3, and total number of classes are also 3, like pneumonia and other. Here the accuracy you can see is 72 percentage, precision is 50 percentage, and recall is 72, and again F1 is 60 percentage. You can the next slide is we discuss about the ResNet model, in which ResNet is a type of deep neural network architecture. These deep neural networks can sometimes suffer from the problem called vanishing gradient problem, which can make it difficult for the network to learn. Here, ResNet helps to evaluate this problem by introducing residual blocks. These residual blocks allow the network to learn the differences between the input to the layer and the output of the layer, which can help to improve the overall performance of the network. And the final output also here predicts which class it belongs to. Here we can see in the red box where the ResNet 50 with some X amount of parameters, it constitutes the bulk of the model's complexity and capability. Here the global average pooling comes under by helping in reducing the overfitting or minimizing the total number of parameters in the model. Here as well the dense to gives the accurate results. Next slide, please. As per this is the skeleton, you can check the confusion matrix, and here the precision and the recall and the reference scores as well. Next slide. Coming to the RNN network, here we can the RNN specializes in processing sequences for tasks such as speech recognition or language modeling. Here it is capable of maintaining information in memory over time to capture temporal dependencies, like effective for analyzing time series data or sequential data like audio signals, whereas past information influences the current state. Same as here it uses the LSTM. Later the dropout and the LSTM1 is used for the exact output, which clarifies which output it is. Next slide, please. Here, the dropout, which is really helpful for to combat the overfitting by forcing the model to learn like more robust features. Here, well as the LSTM1, it helps to return sequences, preparing the model for the final classification. And again, the dense, which helps to reducing the overfitting. And coming to the next model, which is helped to build the accurate image data set. Next slide, please. Here comes the next slide. Here we discuss about the LSTM, in which LSTM is a fancy RNN that learns long patterns in data, like good for time stuff, pictures, talking and hearing, and again great for understanding moving pictures by remembering the changes over time. As per we discussed, we have taken the particular image, and then we did this image data description by using the inspection v3. We did this feature extraction. We extracted the features, and we then put into LSTM model. It calculates the results and produces the dense, in which dense what it does, it flatten the images in the particular order to generate the predicted output. Here, at last, we can see out of the 15 classes, it shows which exact disease it is, like African swine disease, fever. Next one, please. Coming to the mobile net, here it is a smart mobile models for phones and tiny computers, and quick and small but still accurate, thanks to special math, in which it easily calculates in within instant movements. Will helps phones see the things fast without using too much power, like recognizing faces and or quickly. Here also we did the same thing, like uploading the image, and after using the inspection v3, and we can extract the features in order to what it generally supplies to the blockchain, and later global average pooling is mm, plays a key role to provide the valuable generated predicted output. So at last, we'll get the result as a African swine fever. Coming to the next slide, please. Okay, here is the final model comparison results, in which excuse me. Okay, in which the model scores are displayed. This classification, task analysis, machine learning models, which used audio data by comparing the models on accuracy, precision, recall, and FN score. Previously, we performed on SVC, DT, and RF DenseNet models, which does not perform as expected. And the improved models that we chose currently shows a clear improvement in their performance. Is RNN displays higher values out of all other models. The RNN stands out of the highest accuracy of 81% and FN score of 80.99%. Coming to the next slide. So here comes a case study in which we generally take an audio file as an input, in which it analyzes the accurate model for the classification to generate the results in the confusion matrix format. For example, I can see in the result for the truth table 0, it shows a 130. For truth table 1, it shows 16, and again truth table for the second, it shows 21. Next slide, please. Well, for the model comparison, we explored the image classification using LSTM and MobileNet for the image classification. This graph track training and validation loss, where lower is better, in which both the models improve over time, but LSTM achieves a steeper descent and lower overall loss. Coming to the next slide. Here, the second graph here examines the training and validation accuracy, while both the models show increased accuracy with each epoch, where LSTM has a lower training accuracy compared to the MobileNet. However, LSTM maintains a consistently higher validation accuracy, indicating its strength in preventing overfitting. Thank you. Well, the next slide will be talking by Rajiv.
Thank you, Ritik. Coming to the web system design, our web-based system was implemented using web technologies called HTML as a framework, and CSS for styling, and JavaScript for data validation, ensuring user input integrity. And we leveraged the MySQL for database management and PHP for server-side scripting. Our system seamlessly integrates front-end and back-end functionalities to deliver an efficient user experience. Next slide, please. Yeah, as you can see in the picture, our website has 4 tabs on the navigation bar. One is the LAN tab, dataset, prediction, and visualization. So the LAN tab helps users to find detailed information about all the 15 diseases, and the dataset tab provides information on both audio and image data. In the prediction tab, a system predicts diseases using an efficient model like RNN, CNN, etc. Lastly, we use the data visualization to make information easier to understand for the people. Next slide, please. So in the LAN tab, our platform offers comprehensive information on all 15 diseases sourced from Iowa State University, providing users with essential insights to better understanding. This knowledge empowers farmers to make informed decisions, better decisions regarding disease management, and facilitates the selection of appropriate immediate action to address any potential threats any potential threats effectively. Next slide, please. So coming to the dataset tab, we did a lot of research on common pig skin problems, and we collected pictures from Iowa State University Veterinary Department to make sure whether they are accurate or not to understand that model. We chose 15 different diseases showing different skin issues. We also got we also worked on audio data about pigs diseases like pneumonia, PRRS, and African swine fever. Doing this help us understanding these diseases better. Next slide. Coming to the prediction tab. So in this, we have an authorization, like access to the page is restricted to authorized users only, ensuring privacy and security. Authorized users are granted the ability to upload various types of data, including audio and image. Upon upload, our system utilizes classification algorithms to identify and classify disease present in the data or not, like in the image or audio or not. Subsequently, detailed statistics and insights regarding the classified disease are displayed in the visualization in the visualization tab, aiding users in making informed decision and take appropriate action as necessary. Next slide. So in the visualization tab, the platform has a dashboard that shows visualization to help people understand the results. So these visuals give a summary of things like type of disease. Also, it shows how well the model is performing, so users can see it is accurate or not. The dashboard makes it easily for people to make smart choices based on the information and know if they can trust the results or not. Coming to the web-based implementation, in our graphical user interface, users can easily upload audio and image data, initiating the process by selecting from a range of available machine learning models. These models are specifically designed to analyze the uploaded data and generate predictions. Upon the analysis, the model output predict the values with the potential to identify diseases such as African swine fever, as you can see in the picture. Next slide. Now coming to the system design. Here, basically, we have two parts. One is front end and back end. According to our system design, the front end allows users to request response through the website web interface. Multiple frameworks were utilized in the front end to ensure accurate output, as I discussed in the earlier. In the backend, audio and image data were collected and stored in the MySQL database. Subsequently, feature extraction was performed on the integrated data. For audio files, we used MFCC for the feature extraction. For image files, pixel feature extraction was implemented. Following data integration, the integrated data was utilized in the GUI process, where each model was categorized. Under the domain, under the audio domain, we employed three types of models: DenseNet, RNN, and ResNet. For image data, we utilized two models: LSTM and MobileNet V2. These implementations can carried out within .py files. Subsequently, the visualizations were generated separately for both audio and image data. So we use pipelines are established to develop specific scenarios within the system, and the graphical representations are employed to enhance clarity and understanding. And the next step is the data is divided into various segments to facilitate model building. After model evaluation, any incorrect data is identified and handled through error handling mechanisms. So, and at last, accurate predictions are made for correct data. The front end displays the accurate results to the users. Next slide. Yeah, thank you. And coming to the demo part, we are discussing.